So the next things we're going to look at are the non-parametric tests. And I want to try to go through these three all within this one video. So the first one that I mentioned in the introductory video was the Chisquare. And it's used when you're checking for relationships between categorical variables. The test compares the observed frequencies or proportions that occur in cases versus what it thinks should occur or what would be expected if there were no association. So if we ask the question, is there an association between gender and smoking behavior, that being are males more likely to be smokers than females, possibilities are there's males that smoke, males that don't smoke, females that smoke, females that don't smoke, and theoretically ought to be 50-50. So when we actually put our data in and we're keeping track of you're a male who smokes, you're a male who doesn't smoke, you're a female that smokes, you're a female that doesn't smoke. So here's where the frequency counts come out. And what it'll show you is we have 33 people who smoke and 151 who do not. And then for the females, we have 52 who smoke, 200 do not. We had a total of 184 males that smoke, a total of 252 females, 85 total smokers, 351 non-smokers, 436 total participants. And we can account percentage-wise for all of our participants. So the question was, is there a relationship, or do more males smoke than females? So there's a lot that goes into this, but basically what it comes down to, and again, there's some minute detail you're going to learn later on, is we're looking for exact or asymptotic significance. Because this number is not less than 0.05, then we would say, no, it doesn't appear that gender has anything to do with smoking. And if you were to look at this data up here, based upon the percentages, you'd say, yeah, that's probably about right. But the test actually does that for you. And that's all there is to a Chisquare. They're very simple. So the next one is a Mann-Whitney U. And this is used to compare differences between two independent groups, whether they are small, not normal, or ordinal data. So in this example, we asked the question, do males and females differ in terms of their self-esteem? So they were asked a self-esteem survey. This is the non-parametric version of the t-test. And instead of comparing the means to the two groups, the U-test compares the medians. And that's important because we don't want to use means in ordinal data. We'll run the risk of saying something that's true that's not. Again, I want to say, go back to the beginning videos and look at examples of where the right test was used versus the wrong test and how close it can be, and you can make a mistake. So, same thing, it takes the scores. Here's the total number of participants, 436. And it's going to say mean because it does actually end up doing that, but that's not what's running the test. This is the test itself. So there's 184 males, 252 females. And their surveys were ranked. So for example, it took all the male surveys, added up the final score if it was a 4, and then it did the females. And it's trying to figure out if there is a difference between where all the males are ranked in a group versus the females. And what we'll discover, again, is with our asymptotic significance, is there's no difference in regard to gender for the self-esteem scale. Again, it's a very simple test. It sounds like it's complicated. It's really not. The last one that we're going to look at is our friend the Kruskal Wallace. So again, when we wanted to compare two or more groups on an interval ratio scale, we used the ANOVA, which we just saw. And we don't do multiple t-tests over and over because every time you run a test, you get error. Then you start compounding error. So just like we don't want to do that with t-tests, and that's why we use an ANOVA, when we have non-parametrics, it works the same way. When we have multiple groups, we just want a single test. So this is a quick study about locus of control, and that means whether I'm responsible for my behavior or somebody else is responsible for my behavior. And we want to see if there's a difference in the pre-test scores and the post-test scores. And I don't mean pre-test to post-test, but I'm saying for these 9th graders, 10th graders, 11th graders, 12th graders, is there a difference in their pre-test scores for locus of control? So my hypothesis would be 9th graders locus of control is equal to 10th graders locus of control is equal to 11th graders is equal to 12th. And that's my null hypothesis. So my research question is there a difference in grade level regarding locus of control? So here's the output. So I had 28 participants. Here's their ranked scores on their surveys. And what I discover is there is no significant difference in these scores on the locus of control, the pretest locus of control. So let's look at this one. Well, something happened. We did something to these kids, and we gave them a post-test locus of control. Now, I'm not comparing pretest to post-test. I'm just simply looking, causal comparative. What is the snapshot look like? So again, I have 9th grade, 10th grade, 11th grade, 12th grade. I run the Kruskal Wallace again. Now, I do have a significant difference because this number is less than 0.05. So here's the magic question. Would you like to know anything else? Yes, you do. You'd like to know, okay, there's a difference. Where is the difference? Here's the downside of Kruskal Wallace, is it does not have a post hoc test like an ANOVA does. And there's different solutions that have been hypothesized to that. Some people say, well, you can estimate where you think the differences are, like between 11th graders and 12th graders, or 10th graders and 11th graders. We'll turn up the alpha level to like a 0.01 instead of a 0.05. So you decrease the likelihood of making a type 1 error and test it and see if that's where the difference is. I've also seen people say, okay, well, I know this is true using a Kruskal Wallace, so I'm going to take the same data, since I'm securing my outcome, run it as a ANOVA with a post hoc test, and turn up the alpha level for that. Because now I'm not just simply relying on the ANOVA. I've actually done the right test to begin with. Now I'm just taking it up a notch to see if I can figure out where the differences are. I honestly, I don't know if that's the right thing to do. It seems reasonable to me. So I guess we can do that until somebody tells us different. So that's the last of the videos, and I will post a couple of assignments for the groups to work on.